Okay, so this section we want to talk about inconsistent and dependent systems and their application. Okay, so we will apply the Gaussian elimination to a system without unique solutions, to with more variables than equations. Without unique solutions means, what happens? It may be no solution. More variables than equations, what does this mean? Infinitely many solutions. Okay, so we wanted to solve problem involving systems without unique solutions. Okay, so it can be what? No solution or infinitely many. Okay, so inconsistent and dependent system. So if in a case of system with no solution, we call it what? Inconsistent system. Or infinitely many solutions, we call it what? Dependent system. Okay, so it's for these two systems, it's impossible to rewrite the augmented matrix in the desired form, means low echelon form. Yeah, it's not possible because you cannot make it the diagonal all ones and all the others to be zeros. Okay, so now let's first look at the example, a system with no solution. Okay, so if you have x minus y minus z, okay, so what will be the augmented matrix? It's all the coefficient, yeah, 1, -2, -1, 5, 2, -3, -1, 0, 3, -4, -1. How could you make it this one to be 0? It's what? R1 times -2 plus what? R2, yeah? So this will make this one to be 0. What will you do to make the 3 to be 0 here? So R1 times what? -3 plus what? R3. You with me? So make this 0, make this 0. This is your first two steps. Yeah, so you wanted to first rule times. Yeah, so this is R1, R2, R3. It's me? Okay, so what happened here is -2R1, yeah, so R1 times -2 plus R2, -3 R1 plus R3, you get this. Okay, so then what should we do to make this to be 0? Yeah, so what will you do? Your R2, you -2 R2 plus 1 R3, as the way that the book write. So because here is 1, you wanted a 2, 0, so we wanted times what? -2 to get the opposite here. So -2 R2 plus R3. Okay, -2 R2 plus R3. But what happens when you -2 R2 means -2 times 1 plus 2 is 0. -2 times 1, -2 plus 2. It also make what? This one to be 0 too. And then what happens here is 10 times -10 times -2 is -20. -20 plus 16 will give you what? -20 plus 16, which will give you -4. So what does this mean here? You have what? On the left side is 0x 0 plus 0y is 0. And on the right side equal to -4. Could this be possible? No. So it will never be possible. So 0 will not be equal to -4. So what does this mean? No solution. No solution. Yeah. So because 0x, 0y, 0z is still 0. 0 will never be equal to -4. So this is a system with what? No solution. Okay, so the second one is a system with infinite number of solutions. Yeah. Okay, so we have this one. Okay, so similarly we will use what? -2 R1 plus R2 to make it the second rule goes away. It's just to make this to be 0, yeah? Then how could you make this to be 0? Is what? Negative R1 plus what? R3. Yeah? Negative R1 plus R3. Okay? So you get these two to be 0. You with me? And then how could you make this one to go away? To make this one to go away, what will you do? Is negative R2 plus R3. You with me? So because these are the same, yeah? So you negative R2 is will be 1, negative 5, 4. So, but what happened here? You have the last equation is what? 0x plus 0y plus what? 0z equal to what? 0. Oh, that's, of course, that's true. So it's fine, yeah? So then how could we find y and j? Yeah, so the third rule is fine, yeah? So we only have what? 2 equations, but we have 3 variables, yeah? So how could you solve 2 equations when you have 3 variables? So what will you do? So when you have what? JC is the equation, JC is another equation. What will you do? Okay, so JC is called what? We were introduced called what? Free variable. Okay, so we wanted to solve one variable, so let that one variable to be free. Yeah, so how could we choose? Okay, so we wanted to isolate the easiest one. So y minus 5z equal to 4. What will you do? Is what? Y equal to what? 5z plus 4. Are you with me? Then what is this free variable? J is your what? Free variable. Okay, so what do you wanted for x then? You also wanted x to be what? In form of j. So you wanted what? Substitute y equal to 5z minus 4 minus j. Then what do you want? You wanted x to be in form of j too, because j is your free variable. Okay, so it's just like a special number here, yeah? So everything is in the form of j. So x will be what? 11j plus 13. Y equal to what? 5j plus 4. J is j, yeah? So this is why you call it what? Dependent system. Okay, dependent system, where one variable is free variable. One variable is free variable. Okay, so JC is this one. Okay, so JC is what? This one. Okay. Okay. So another example is a system with fewer equations than variables. So when a system with fewer equations than variables, what should we do? You definitely will have a free what? Variable, yeah? Yeah, you will definitely have what? Infinitely many solutions. Okay, so similarly, which one do you want it to isolate? Y, because y is easier to solve, yeah? So y equal to negative 2j plus 10. Then you substitute what? For x. So you will have what? You find x equal to j plus 15, negative 2j plus 10, and j. And j is the free variable again. But it does not always, j is not always, yeah? So because if you have 2y plus j equal to 10, yeah? So what will you do? You can certainly solve for j. So it doesn't mean that j is always the free variable. It all depends on which one is easier to find. Are you with me? Are you with me? Okay, so thus depending on which variable is easier to isolate. Okay. Okay, so this is the